Hello everyone, welcome to M Math Academy. Today we are going to explain another important chapter in mathematics, which is trigonometry. Trigonometry is a branch of mathematics which is very large topic, and in this video I am going to give you the introductory concept in trigonometry. So in this video I am going to cover few items like introduction to trigonometry, applications of trigonometry, angle of elevation and depression, trigonometry of right triangles, leveling of right angle triangles, trigonometric ratios or functions, and reciprocal trigonometric ratios. Let's start. Introduction to trigonometry. What is trigonometry? Trigonometry is an important branch of mathematics that focuses on the study of relationships between the sides and angles of a triangle. Origin of the word trigonometry. Where does the word trigonometry come from? Latin derivative trigonometria, which comes from the Greek word trigonon, meaning triangle, and metron, meaning measure. So, as the name suggests, trigonometry is all about triangles. Example, let's consider this triangle ABC. In this triangle ABC, as we can see, the sides are AB, BC and CA. So the sides are AB, BC and CA, or the side lengths are lowercase c, lowercase a and lowercase b, and angles are A, B and C, angle A, angle B, angle C. And trigonometry simply focuses on the study of the relationships among these sides and the angles of the triangle. Trigonometry uses other branches of mathematics like algebra and geometry, etc., to determine the unknown lengths and angles of a triangle. Now, the applications of trigonometry. Why do we need trigonometry? What is the purpose of using trigonometry? So here I am trying to give you a basic idea. Why do we need trigonometry? Trigonometry is a mathematical system that helps working out missing or unknown side lengths or angles in a triangle. Let us consider an example. Suppose we have this diagram here. Let me explain. Suppose AB equal to height of a building. This AB is the height of a building. AC or AD, these are the positions of a ladder, extendable ladder. We can say AD is the ladder, and we can extend that ladder up to this position AC if needed. So AB is the height of the building and AD is the ladder which can be extended up to AC. That means the angle is being changed. So alpha or beta, these are the angles the ladder makes. Alpha or beta. Alpha is the angle the ladder makes with the ground when its position is AC. Again, beta is the angle of the ladder AD it makes with ground when the position of the ladder is AD. So this is we are not going to solve anything here. I am just trying to give you an idea what is the purpose of using trigonometry. So in this case we can see that trigonometric functions are required to solve this problem. So in the next page we will show you how we can apply trigonometry to solve this. Applications of trigonometry miscellaneous. What are the other applications? Trigonometry has a very wide range of diverse applications. It is extensively used in various fields like calculus and other branches of mathematics. This one is mostly related in mathematics. Then other topics or other fields where we use trigonometry are like determining height of buildings or mountains, architectural and different engineering sectors, navigation, marine biology and military fields, criminology to calculate projectiles trajectory, oceanography to calculate the height of tides, meteorology, weather forecast and seismology, manufacturing industry and construction fields. So these are all about different applications in different fields of trigonometry. Now, angle of elevation and angle of depression. Suppose standing at a height A, we are looking at a flying helicopter X on the sky at a distance. The angle between the horizontal line of the line of sight and the line of sight up to an object is called the angle of elevation. So in this diagram we can see A is the height of a building or whatever. So A is a height, and from A an observer is looking at a flying helicopter which is at X. So this angle theta 1 is the angle of elevation from the observer A at A to the object at X. This is called angle of elevation. Similarly, now suppose standing at the same height A, we are looking at a boat Y on the lake at a distance. The angle between the horizontal line, this dotted line is the horizontal line. The angle between this horizontal line of sight and the line of sight down to an object is called the angle of depression. So this theta 2 is the angle of depression from the observer at A to the object at Y. So this theta 1 is the angle of elevation from the observer at A to the object at X, and theta 2 is the angle of depression from the observer at A to the object at Y. Now another explanation here about angle of elevation and angle of depression. So this theta is the angle of elevation from the observer at B to the object at A. So observer is at B position looking at this object at A. So this angle theta, which is the angle between this line and the horizontal line from the observer, is the angle of elevation. Similarly, theta is the angle of depression from the observer at A. Now, if the observer is A and this observer is looking at the object at B, then this angle theta is the angle of depression. So, if the angle of elevation from A to B is theta, then the angle of depression from B to A is also theta. In other words, if the positions of the observer and the object are interchanged, the angle of elevation equal to angle of depression. Now, trigonometry of right angle triangles. In any right angle triangle, only one right angle 90 degree and the other two angles are acute angles. One of the acute angles is labeled as theta. The side opposite to the right angle is the longest side, which is called hypotenuse. The side opposite to the angle theta is called opposite. The side next to theta but not the hypotenuse is called the adjacent. Look at this diagram. So ABC is a right angle triangle. The right angle 90 degree is here at B, angle B. And now as soon as we consider this is the right angle, the opposite side is called hypotenuse. So AC is hypotenuse. Now between this angle C and angle A, any one can be considered as theta, and based upon that, if angle C is theta, we will call AB as opposite and BC as adjacent. But if angle A is theta, then BC will be opposite and AB will be adjacent in that case. So in any trigonometrical study of a right angle triangle, the orientation of the triangle is not important, but the angle theta for which the trigonometric ratios or functions being considered is extremely important, and based upon that, the hypotenuse is opposite and adjacent are determined and labeled accordingly. Now, labeling of a right angle triangles. It is extremely important to identify hypotenuse, opposite and the adjacent of a right angle triangle regardless of its orientation, because based upon that the trigonometric functions will be determined. So there are different orientations of a right angle triangle, and based upon the angle theta, the opposite, adjacent, these are determined. So it does not matter how the right angle triangle is oriented, but most important thing is which angle is theta. Easiest way to identify is hypotenuse is the longest side opposite to the right angle, and it is very straightforward. Opposite is the side opposite the angle theta, and adjacent is the remaining third side. So suppose in this triangle, if this angle is theta, opposite side is opposite, and apart from hypotenuse the other side is adjacent, because hypotenuse is very straightforward. It is always opposite to the right angle. If this is right angle in this triangle, then this is hypotenuse. In this case this is right angle, so the opposite side is right hypotenuse. But based upon the angle theta, opposite of that angle theta is called opposite, and the remaining third side is called the adjacent. Now, trigonometric ratios or functions. There are 6 basic trigonometric functions. The sine of angle theta is called sine theta, which is opposite over hypotenuse. Cosine of angle theta is called cos theta, which is adjacent over hypotenuse. Tangent of angle theta is called tan theta, which is opposite over adjacent. Cosecant of angle theta is called cosec theta, which is hypotenuse over opposite. Secant of angle theta is called sec theta, which is adjacent over hypotenuse. Cotangent of angle theta is called cot theta, which is adjacent over hypotenuse. Now this seems like very confusing. There is an easy way to remember or figure out. Let me explain it, how to remember these different trigonometric ratios. So in order to do that, we should remember this code language, which is called SOHCAHTOA, SOHCAHTOA. What does it stand for? So so is sine, which is opposite over hypotenuse. So S stands for sine, O stands for opposite, H stands for hypotenuse. So sine is opposite over hypotenuse. That is indicated by SOH. So next is CAH, cosine is adjacent over hypotenuse. Cosine C, adjacent A, hypotenuse H. So cosine is adjacent over hypotenuse, that is indicated by CAH. And TOA, which is tangent, is opposite over adjacent. So T stands for tangent, O stands for opposite, and A stands for adjacent. So SOHCAHTOA. This can be very helpful to figure out sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over hypotenuse. Sorry, tan theta is opposite over adjacent. Now reciprocal trigonometric ratios. In right angle triangle ABC, hypotenuse is AC, opposite is AB, and adjacent is BC. Now sine theta is, we know sine theta is opposite over hypotenuse. So in this case, opposite is AB and hypotenuse is AC. So sine theta is AB over AC, and cosec theta is AC over AB. So we can conclude sine theta is 1 over cosec theta, or cosec theta equal to 1 over sine theta. Similarly, cos theta is BC over AC and sec theta is AC over BC, which means we can conclude cos theta is 1 over sec theta, or sec theta is 1 over cos theta. Similarly, tan theta is AB over BC and cot theta is BC over AB. So we can conclude tan theta is 1 over cot theta and cot theta is equal to 1 over tan theta. There is another relationship we can establish from here, which is tan theta is AB over BC, and AB over BC can be written like this: AB over AC times AC over AB. Just we are giving another shape to this AB to this ratio. So AB over BC can be written as AB over AC times AC over AB. So AB over AC is sin theta and AC over AB is equal to 1 over cos theta. So tan theta becomes sin theta over cos theta. This can be used later, we will discuss again, but just for the time being we can memorize tan theta equal to sin theta over cos theta. Now reciprocal trigonometric ratios conclusions. So we can conclude sin theta and cosec theta are reciprocal to each other. So sin theta is 1 over cosec theta and cosec theta is 1 over sin theta. cos theta and sec theta are reciprocal to each other. So cos theta is 1 over sec theta and sec theta is 1 over cos theta. Tan theta and cot theta are reciprocal to each other. So tan theta is 1 over cot theta and cot theta is 1 over tan theta. Remember, there is a note, important note here. 1 over sin theta is equal to sin theta whole to the power minus 1, but not equal to sin inverse theta, because this sin inverse theta is a completely different topic. Inverse functions we will discuss later, but for now what is most important is 1 over sin theta is equal to sin theta to the power minus 1, but not equal to sin inverse theta. Inverse function is completely different. There is a worksheet here, you can try. If you have any problem, you can send me a comment. I can try to help you. Now that's the end of this video. Thank you for watching, and don't forget to like, share and comment, and most importantly, please subscribe my channel.